This is section 3.4, direct variation. So direct variation has an equation of the form y equals kx. Now a lot of people like to think about it as a slope-intercept form, y equals mx plus b, because this one comes up a lot more. And then direct variation is just a special case where b equals 0. And m, remember we talked about in the last section, is our slope. So y equals mx could be another form of direct variation since b is 0. K is the constant of variation, or our slope. So when it asks for that, that's what it's talking about. So example 1, name the constant of variation. So remember y equals kx, or you can do y equals mx. Either way, the slope and the constant of variation are the same number. They're in the same spot. So in these two examples, -4 is our constant of variation, and 1/2 is our constant of variation, or slope. Graph the direct variation equation. Okay, so you need your x and y axis. Now, in the previous section, we were talking about finding slope, and we did some of those off of the graphs. And to find the slope between the points in the graph, we would do, like, say a point was here and a point was here. We would count how many rise and how much run to get from one point to the other, and that was our slope. So we're going to use that same idea here. Remember, since these are direct variation, there's no number after it, so it's 0. So both of these equations are going to start at 0 because there's no number at the end. Now, like I said, we're going to use this rise over run idea. So here 6 is our slope, or our constant of variation. So I want to make that a fraction so that I have a rise and a run. So 6 over 1 is the same as 6. So from that point of 0, since it's direct variation, it needs to go through the origin, I'm going to rise 6 and run 1. So since these are positive, this is up 6 because we rose, and right 1 because that's also positive. Now, 2 positives and 2 negatives end up being the same thing. So you could also go down 6 and over 1. And that barely fits on my screen. And then you could draw the line between those. If you only did the 2 points, just be careful, make sure it's straight. And then you guys would use a ruler so that your line is way straighter than mine. So let's look at this next one. Again, starts at 0 because it's direct variation. There's no number here, so it's a 0. Now the negative can go with either number, so you could think of it as -3 over +4 or +3 over -4. It doesn't matter. Let's do both. So remember, this is the rise, this is the run. So rise -3 means I'm going to go down 3, and then run +4 will be right 4. And then if we do it the other way, 3 over -4, we rise +3 and run -4, so that would be left 4. And all 3 of those points should line up, and you can draw your line. Perfect. The last thing is write and solve a direct variation equation. So remember, we're going to think of those as y equals mx. Suppose y varies directly as x, so direct variation, we use that equation. Y is 72, so we can plug that in where the y is in the equation. And x is 8. But we don't know m, so we need to find that. Now, because those are right next to each other, that's multiplication. So I'm going to divide by 8, and m is 9. So when they say write the equation, they just want the number filled in for m. So y equals 9x would be my direct variation equation. Then part B says use that direct variation equation to find x when y is 63. So since y is 63, I'm going to put that in where the y is, and solve for x. So 9 times x, so you divide by 9, and x is 7. And that's all there is to direct variation.